The last slide for today is just an overall look of all of these different types of formulas that we looked at today. The Lewis structure is going to be the most complete, and that shows all of the atoms and all of the bondings and all of the lone pairs that are present in the structure. The skeletal form is going to be our preferred method for organic chemistry because it is the simplest form. So if we were to transform this Lewis structure into a skeletal form, we would end with something that looks like this, where we have 4 carbons, and in between carbons 2 and 3, we would have a double bond. The condensed form would tell the reader exactly how all of the atoms are attached, but no bonds would be shown. So for this first example, you would tell the reader that carbon number 1 has 3 hydrogens, carbon number 2 has only 1 hydrogen, carbon number 3 has 1 hydrogen, and carbon number 4 has 3 hydrogens, but none of the bonds are going to be shown. The new column for this table is going to be the molecular form. The molecular formula is going to be the one that is going to tell you the least information about a compound because it literally only tells you the overall amount of each element in the structure. So for example, in this first example, we would have a total of 4 carbons and 8 hydrogens. So the molecular formula would be C4H8, which would tell you how many atoms there are, but nothing about the connectivity of these atoms. All right, now let's do another example. Here we have CH3CN. If you were to draw this structure in skeletal form, you would end with something like this. Now please note that usually when we have triple bonds, we tend to draw things straight, and the reason for that is because of the geometry of the molecule, and this is something that you will be learning in the next lecture. The condensed form would be CH3CN, and the molecular formula would be C2H3N. Let's look at another example. So for this structure, we have a CH3, which is attached to a C double bond O. And then this hydrogen here on the right is usually shown when we draw a structure, but if you left it invisible, that would still be okay as well. Now the reason why it's shown is because this is an aldehyde, and we show it to differentiate it from a ketone, or sometimes because we are working with reactions. But if you did not show the hydrogen, that would still be correct. The condensed formula for this structure would be CH3CHO. This CHO ending is very characteristic of an aldehyde as well. And the molecular formula for this structure is C2H4O. Next example, we have 2 CH3s, one on the left, one on the right, and then the central carbon contains a C double bond O. So the skeletal structure would look something like this. The condensed formula would look something like this, where we would tell the reader how each atom is connected, and the molecular formula would be C3H6O. The next example, we have this skeletal formula, and for the condensed structure, there are 2 options that are very commonly seen. The first one would be by drawing each oxygen by itself, whereas the second one would group the 2 oxygens with a subscript 2 to indicate that there are 2 oxygens in this structure. So either one of these condensed forms are going to be correct, and you will see both throughout the semester. The molecular formula for this structure is going to be C2H4O2. The last example is what we call a ring. The skeletal formula is going to be simply A square. The condensed formula is going to actually keep the bonds in this case. And the reason why it keeps the bonds is because we need to tell the reader that all of these CH2s are connected in a ring form. If we just wrote all of these CH2s in a linear form, that would tell the reader that the structure is actually linear. So only for cyclic system we keep the bonds for condensed forms. Finally, the molecular formula for this structure is going to be C4H8. And one very interesting thing that I want you to notice is that the molecular formula for the first and the last structure is exactly the same, which shows you that the molecular formula by itself does not really tell you a lot of information about the molecule. The condensed formula is much more detailed. The skeletal and the Lewis structures are going to give you much more detail about what a molecule looks like.